Hello students, welcome back. Let's resume our problem set. And this is the original exam problem set I used several years ago. We just went through the first problem. This is a setting, sample statistics are kind of like these, and we just found out the 95% confidence interval for the mean. The next problem is asking you to find out a 95% prediction interval for one individual randomly selected number. So what's the difference between confidence interval and prediction interval? One is about the mean and the other is about the individual. Here's an analogy. What if you predict an average temperature of March of a certain year? You can do it relatively accurately, which means the margin of error is pretty small. Now how about a high temperature of any given day? Well, that's very different. You have really wild swing. You cannot predict the weather. That's because you're looking at the difference between the confidence interval and the prediction interval. Confidence interval, we found out, was much smaller, and we had what? 7,000 to 7,400 approximately speaking for this particular case. And the prediction interval for each individual number will be much bigger than that. Remember that. Okay, how do we actually do it? Step 1, we begin with an initial picture. A t-curve with, okay, we have center 7,203.091 psi. That's the observed mean, so that's the center. No question about that. And 95% in the middle, which means 5% will have to be shared by left-hand side here, blue, 2.5%, and the right-hand side, another 2.5%. Same setting. Now, let's go to the next step, and the big difference here is the standard error. Instead of this previous denominator, previous standard error of s over square root of n, we have something different. S times 1 plus 1 over square root of n. Basically, it's this one. SE is standard deviation over square root of n for confidence interval. Here in this case, S is equal to S times square root of 1 plus 1 over n. And this quantity is much bigger. Here, S is divided by square root of n, which can be relatively large, so this value is much smaller than S. How about this one? S times square root of 1 plus something, so this quantity over here is greater than S. And this is as small as it can get by taking really large n. This one, if you take really large n, this 1 over n will become really small, pretty close to 0, but overall, this will stay above s. So the denominator is not going to be that small. Does it make difference? Oh yes. Okay, let's go to this, and then let's do the problem. Instead of s over square root of n, we have different formula here. S times square root of 1 over 1 plus n. And then look up this t-table. And when we have 95%, here's the t-table. And the degree of freedom in this case is 29. There are 30, so 30 minus 1 is 29. So we have it here, 29. Over here. Okay, all right. And then which one of them represent 95%? Over here. So 2.045. That's the t-statistic that we are looking for, 2.045. All you have to do now is to solve this equation algebraically. Let's do that. This is a standard deviation, 5.42.540, and times that figure, and that's going to be the denominator. And the numerator is the same as before, n minus center, x minus the center. And that is equal to this t-statistics. So all you have to do is flip over this denominator to the other side by multiplying, which I did over here. And then flip over this one to the other side, and so that we have addition. So we have center plus t-statistic times standard error. Run your calculator. What do we have? 8,330.925. That is the right-hand side endpoint here. And let's look for the left-hand side endpoint. We use the symmetry. From the center, plus t times SC versus minus t times SC. We are going backward. And there we go. Change this plus to minus from the symmetry. And run your calculator. You got 6,075.257. And that is my prediction interval. By the way, here's a picture. If you look at this one alone, then you cannot see any difference between the confidence interval and prediction interval. You have to look at the numbers. Prediction interval is going from about 6,000 to 8,030 something. That is the prediction interval for each individual number. Now, if you go over to confidence interval for the mean of 30 numbers tested, you go from 7,000 to 7,400, approximately speaking. Look at this size. Size is about 400, so margin of error is about plus or minus 200 max. Let's go down here. 6,000 to 8,300 something, so about 2,300. That's the interval size. So margin of error is about is half of that size, so it's about 1,650, 1,600 something, plus or minus. That's the margin of error for each individual number. For mean, we have the margin of error of about 200, much smaller, much larger. See the difference? That's the difference between the confidence interval and a prediction interval.